Hi there, and welcome to our last speaker session here at cluecon Deconstructed. It's been a great day so far. We've had some excellent speakers, some great open source community contributors yesterday as well, and of course on the first day of the workshops. It's all been very good, hasn't it, Abby?
Oh, it has been wonderful. I'm so glad that we were all able to get together, and we're going to be able to continue getting together tonight in about an hour and a half at the Gigabit reception at 4:30 Central until 6:30 Central. It's going to be so much fun. We're going to be having karaoke. We're going to have an open jam room. So if you want to bring your instruments, you can show us your talents there. We're also going to be streaming a movie, which happens to be my favorite movie, Star Wars: A New Hope, Episode 4. So if you're interested in that, check it out. We're also going to have a couple rooms open. If you just want to chat and you don't want to sing karaoke, we'll have that as well. So make sure to bring your own drinks tonight at 4:30 as we have our virtual networking event. And as we slowly start to say goodbye, as this is the last session, I just want to remind everybody to follow us on our social media. You can follow us on our Slack channel at SignalWire.community. We'll be posting updates about next year's cluecon. There's also a free switch and a SignalWire channel in there as well if you ever have any questions. And we'll be posting on our Facebook and Twitter accounts as well to keep you guys updated about what cluecon is going to look like next year. And maybe even post a couple of pictures, some screenshots up there of cluecon Deconstructed so everyone can see how fun it was. Also, if you're so sad that the presentations are over, don't worry, we have been recording everything. We've been live streaming on YouTube this whole time, so if you missed anything, you can always go back and check it. We also have cluecon weeklies every Wednesday with David Duffett here. So if you want some more great content from the Free Switch cluecon team, check out our YouTube channel. It's Free Switch on YouTube. And the last announcement I have is just that we're going to be giving away our grand prize, our laptop, as soon as these talks are over in an hour. I'm so excited. It's custom engraved. It matches the cluecon t-shirts that we're going to be giving everybody who participated. Don't worry, we've got your emails. We'll be sending you an email on how to get your free t-shirt. And here's a sneak peek at the MacBook Pro. So this is the same picture that's going to be on the t-shirts, but it's much more exciting when it's on a laptop, I think. So keep your ears tuned in an hour. We're going to be giving that away. And that's the last announcement I have. I'm so excited to see our speakers, and I can't wait to give out some free stuff at the top of the hour.
Great stuff. Well, congratulations on these many excellent announcements you've been doing, Abby. You do it very well indeed. And of course, you're very excellent at giving away things too. So we'll look forward to that.
Oh, yes. And thank you for being such a wonderful host, David, throughout our cluecon Deconstructed. It's been so much fun.
It's so enjoyable. All right. Well, bye-bye, Abby. Good to see you. And we'll see you a little bit later. And Jerry Eisner is our first speaker. Hey, Jerry, how are you doing today?
Excellent, David. It's a beautiful day in Ohio.
Well, that's real good. And Jerry, it's not that long ago, maybe a few months ago, that you and I did our cluecon weekly chat. And it was during that chat that I realized what a man of many years of experience in the E911 world you are. You may, like me, maybe a little bit of grey hair from the industry. You never know. We're excited to have you along to do this presentation. Now, you're working for Red Sky Technologies. So before we carry on, let's just find out what they do, please.
So the enterprise, so everybody that has their own multiple line telephone system, whether it's, they buy it from somebody else or it's hosted or everything else, under new FCC rules, they have to be able to find endpoints, whether they're on-prem or off-prem, hard phone or soft phone. They need to use the result of that find to route a 911 call to the location appropriate 911 call center. And then also in the FCC rules, that enterprise has to get a notification that somebody called with the callback number and the location. And what Red Sky does is we work with service providers and value-added resellers and enterprises at all levels and all sizes to make sure that they can be compliant with both FCC and state rules. So find route, notify. We made it really simple.
find, route, notify. 3 very important words. Jerry, we're excited to hear about the world of E911 from you. So let's get your slides up and get you kicked off.
Thank you very much. And, you know, when David asked me to do this, he said, you know, we're going to save the best for last. So don't worry about your slide. And it's like, okay, fine. That's fine. That's fine with me. So I want to talk a little bit today about, you know, what 911 is, some of the history, how we got there, how it works differently in the landline environment versus the enterprise, a little bit of the regulatory environment. And remember that I'm not a lawyer, so I'm not giving any legal opinions. Don't ever do something and say, well, Jerry said, and I don't want to hear it in court. And then some of the technical approaches about how you meet those requirements. And in the slide deck that you'll have access to, I put in some bonus material about what next generation is, what it means to you as the enterprise, and then how cell phones work as well. So why me? So this is year 35 in the public safety communications space. I have product management and regulatory responsibilities at Red Sky. At Intrado, who provides 93% of the nation's 911 databases. I own the products that did that, first for Lucent and then for Intrado. Verizon brought me in to do New York City, and while I was hanging around writing contracts, I did LA and DC. And I've been involved with all these different industry groups. NENA is the National Emergency Number Association. There's a policy board, Next Generation 911 Institute, the National Fire Protection Associations, and other standards bodies. So I get my fingers in a lot of things. And the wealth of experience that I've been forced and lucky enough to be in has given me a broad look at how things work. So today, I want you guys to understand how 911 works, a little bit about why you have to do it, and that's really to keep your names out of the papers, and then kind of look at the crystal ball about where stuff's going to. So at the end of this, you should understand where we were on July 31st of last year and what changed on August 1st of last year. So there's a dictionary. Annie and Allie are old 911 terms that mean the phone number of the calling party, the location of the calling party. CAMA is, for those of you who have gray hair like this, CAMA is a trunking method that carries that phone number in it. And PSAP, I'll use that for public safety answering point. And I put a link in the documentation. Columbia built a great primer on how 911 works. So in the landline world, which could be like interconnected VoIP in a fixed environment, somebody establishes service, they create a service order that says this phone number is at this location. That is sent into the 911 service provider, and they create this relationship of the phone number and the routing code or emergency service number. And then the same thing with the phone number and the location. When the caller dials 911, out of their end office, it goes up to a tandem office that says, I'm going to look up based on the phone number where to route this, and then I'm going to deliver the call to the PSAP. I'm just delivering voice in the phone number. When the call reaches the PSAP has specialized equipment that takes the phone number, uses it as a query key, and then gets the location back and displays it at a call taker. In enterprise, things are a little bit different. So you're going to see FreeSwitch has responsibilities. And when I say players, I mean people who are in this ecosystem of having to maintain 911. So obviously the PBX or call server, so FreeSwitch and Asterisk, Avaya, BroadSoft, Cisco, GenBand, Unify, all of those guys. The hosted guys or the cloud service providers. Mitel just stood up their cloud. 8x8, Ring Central, Vonage, all of those kind of guys have responsibilities as well. And then in the fixed world, whether it be a CLAC or a cable service provider that bundles in VoIP for voice, they have responsibilities as well. And typically what happens is you're going to have to, again, cover these endpoints. And I always envision endpoints as being part of a quadrant. So it's going to be a hard phone or soft phone. It's going to be on-prem or off-prem. And those four things all have to be accounted for when you're talking about 911. And in the enterprise space, user mobility is key. The ability for me to take my device, whether it's a tablet or a hard phone, and move it, whether it's around the building or between the building and home, or now in the work from anywhere environment, wherever I can find Wi-Fi. User mobility is key. On the regulatory environment, the FCC on August 1st said, hey, look, MLTS, multiple line telephone systems for 911 is the forgotten stepchild. We're fixing that. And they passed two laws. One is Kerry's Law. The other is Section 506 of the Ray-Baum Act. And at a high level, it says you've got to provide dispatchable location of the device plus the notification. One of the other key points in Kerry's Law, and this is more on your side than it is on mine, is you have to allow direct dialing. Direct dialing says you can't require somebody to dial 9 or any other digit before they dial 911. The dial string of 911 has to create a call. So in the enterprise, we have our own kind of dictionary. Obviously, DID is a phone number associated with a device for inbound calling. ELIN is a dialable phone number that is associated with a location. And that location is associated with a network connection. So let's say you're on a university campus, you've got a cafeteria, and you stick a Wi-Fi access point in there. And all faculty and staff and students that have your soft phone client can go in and out of that. Well, when 911 is dialed, you don't want to have to go to the 911 system every time somebody registers with that access point and say, oh, they're now in the cafeteria. So there's applications that will say, oh, I see a registration event. It's with this BSS ID. I know it's at 123 Main Street, 4th floor cafeteria. And I can do that programmatically and in real time. That address that I just gave you is either the emergency response location or the URL or the dispatchable location. Now, when I have out of my call server, when I'm going to deliver a 911 call, if I'm going beyond my local jurisdiction, because I'm supporting soft phones that can be anywhere, I'm going to use something called a VPC, a voice over IP provisioning center. They maintain boundary maps of every PSAP in the country that says, when I do a point and polygon lookup, I know how to get the call to that PSAP based on location. So how does it work? How do you deploy this? So first you have to build a wire map, and the wire map can be as granular as the customer wants. And that's what the FCC said. The FCC said the enterprise knows their footprint better than anybody. So they get to decide what a dispatchable location is and how granular to make it. So in layer 2, you can say this switch and this port equals a dispatchable location. You might just say this switch is a dispatchable location. You could do it by IP subnet. You can do it by access point. You can do it by DID in a static environment. Think like a fax machine that's got a handset on it, or a wall phone. They're not going to move. They're not going to be dynamically discovered. So you're just going to say, well, this phone number is at this location. And then this 911 management system that's doing the find when an IP address changes or there's some other trigger event, it performs a table lookup because it gets a registration event from the call server. And it says, oh, let me go poke the network and figure out where that IP is. So SNMP, it goes and it pokes the MIB and it pulls it back and says, I figured out what chassis and port you're associated with, or I got the BSS ID, or I'm just going to use IP and look at that subnet. And I'm now going to associate the device with that emergency response location that has an ELIN associated for outbound calling. So now when somebody dials 911, and there's two flavors of this. And I mentioned that if you're in one jurisdiction, so there's no soft phones involved and you're serving a school district and they're all in your town, you can send that call back to the PSTN. So somebody dials 911, the call server substitutes the ELIN that was discovered based on the URL for the DID. It also stores the DID to ELIN relationship in case the PSAP calls back looking for the caller. That call's routed to the PSTN. The end office says, I've got 911 as the called party. I'm sending that up to the selective router. The selective router dips with the ELIN as the phone number. It gets the routing code, that ESN, delivers the call to the PSAP. The PSAP has the ELIN as the calling party number. It queries with the ELIN and it gets the location, and they dispatch fire, police, or emergency medical. When you're using soft phones or your call server serves a geographic area that goes beyond a single PSAP. So same thing, user dials 911, the PBX is still going to do that substitution, except now instead of routing the call to my PSTN provider, I'm going to route that to somebody like Red Sky. We look at the pre-provisioned location to determine which selective router to send it to anywhere, United States and Canada, and we deliver the call with the appropriate keys so that when the PSAP queries locally with that ELIN, the ALI database knows to make a second query to us. We respond with a location. That location is then delivered back to the PSAP. It's called a steered query. All this happens in milliseconds, like 23 milliseconds last time I put a clock on it. So the other thing that this newer technology, and this starts to get into next gen, instead of just passing the ELIN to us, we're actually inserting the location, and it's something called PIDFlow, presence indication determination format of a location object. It's an XML string, and that's in the SIP invite that comes out of the call server. And now, so the VPC, we get that SIP invite, and embedded in the SIP invite is that location token. We use that location token to figure out where the selective router that serves the PSAP is, and everything happens in the same way. It's a newer technology. The biggest difference is in an ELIN environment, somebody's got to pay for those DIDs. So let's say you're talking to a school district and they have 1,000 classrooms and they want granularity to be down to the classroom. Well, what that means is somebody's got to go buy an extra 1,000 DIDs just to assign one to every classroom. In the next gen environment, you don't need that because every phone call is going to include its location information. On the regulatory side, it's so important to understand both what's happening at the federal side and at the states. And I put up here, they have some form of regulation. In California, the state regulation says the service provider should provide a brochure talking about the limitations of 911. Okay, well, if we should, yeah, forget it. If you look at Florida and Louisiana, they say you got to provide location down to the desktop. Okay, there's a difference. And if you're in multiple jurisdictions, some may have no state legislation, some may have weak, some may have strong. Make sure you treat everybody equally. So when you treat everybody equally, you pick the toughest law and you apply it to your whole system. Then on top of that, last August, the FCC adopted these new report and order that included Kerry's Law, and I mentioned direct dial and notification. It included the definition of dispatchable location, although it doesn't say it's every 7,000 square feet. It says it's intent-based. Make sure you can use the location to route the call, that the call taker knows who to send, that the first responder, and again, police, fire, and EMS, can use it to find the caller, and in that notification that the enterprise can assist the first responder in getting to the caller. Think about a college dorm that's locked after 11 o'clock at night. Well, that call that comes out at midnight, somebody's going to have to open the door so the first responder can get there. The enterprise knows that lights and sirens are coming because they got the notification and where to go. And then I put overruled on there. So there's a couple things. There's no exceptions in the federal law. There's tons of exceptions in the state laws. And the second part is the FCC did not want to overrule the states. So if the state laws are tougher, more stringent than the FCC, the state ones still take precedence. If they're weaker or silent, then the FCC takes precedence. The Ray-Baum Act, it kind of defines the difference between static and nomadic. So in my mind, if a device doesn't move during the normal course of business, it's static. So even if I take a soft phone client and put it on a tower computer, I'm not going to unplug my tower computer and take it into the conference room. So that's static. If I have that same soft phone client on a tablet and I carry it around, that's nomadic. And there's different timelines for compliance based on whether you're on-prem, off-prem, static, or nomadic. So some of the important dates, if you guys are deploying anything after Feb 16 of this year, you have to be compliant with direct dial and notification. Now, if you do a major upgrade to the core after that date, you have to become compliant. So if it's when you have that trigger of an enhancement, that's when you've got to be compliant with direct dial and notification. So if you don't do anything to that system, so it was grandfathered in because it was deployed before Feb 16 of 2020, all hard phone on-prem devices needed a location by January 5th, 2021. All other devices, January 5th, 2022. Here's a free hint. Don't create two classes of employees' safety based on what kind of phone they're assigned. So if you're going to do this for on-prem hard phone by January 5th, 2021, just do it forever. So some people do static or good enough. That means in a small enterprise, and I see it typically around maybe like 200 devices. So under 200 devices, if people move, I can go and I can manually update this. As soon as I deploy soft phones, I can't do that anymore. So you got to think about that in terms of, do I want to just do static? The dynamic talks about that wire map and programmatic approach. I can tell you when you deploy systems like this, the long pole in the tent is building the wire map. I was on the phone today where they said it's a big chemical company. We have 54 locations. And it's like, okay, somebody's got to do a lot of work to build that wire map. And understand that there's no limit on where those systems are because you're going to use a VPC. And know that this approach meets all of the regulatory requirements. And by the way, the free switch guys who are putting out these systems, there's a liability associated with you as well. I think that there's an interesting premise in terms of FCC liability in open source. I don't know who the manufacturer is, but the FCC definitely said that whoever installs it and the customer are both on the hook to make sure that you're compliant. So in the dynamic, you got to build the wire map. You've got to have the what network connection equals what dispatchable location. You need ELINs depending on what kind of service you are. For off-prem, there's typically a client that says, I don't recognize where you are, please tell me. Sometimes they're assisted with public maps. And you got to remember that public maps and GPS are street level only. So if you're on the 10th floor of a building, it won't know you're on the 10th floor of the building. If you're in an urban environment, you'll be lucky that it knows what building you're in. So the app allows you to put in that granular location. So who does this for you? In the dynamic location, it's a third party. Company called Bandwidth, Comtech, and Telequint, Intrado, Red Sky, they do that routing. So if you figure out how to do the find, these companies will take your 911 call, and even if you're provisioning the ELIN statically, okay, and you're figuring out ELINs on your own based on subnet, it's not rocket science, but you're sending us a 911 call with the ELIN in it as the calling party number, we'll deliver it where it goes. If you need help on the network discovery, and again, Intrado, Red Sky, Microsoft Teams with direct routing does some of it. Zoom has some limited capability, and there's a couple others out there that are homegrown, but are doing that fine. And typically it's based on subnet, which may not give you the granularity unless you want to go down to subnet of 1, which nobody really wants to do. So where's this going? Well, the capabilities on the technology side is advancing faster than the regulations. That FCC order, just so you guys have some idea of how quickly the FCC moves. I was at a presentation in 1995 that said to the FCC, this is a problem, you have to solve it. It got solved on August 1st, 2019. That's, David was making fun of me of where the gray hair came from. That's where this stuff comes from. There's tons of standards. There's a standard for this next generation 911 that I started working on 20 years ago. The first version was published in 2019. The next version may be published in 2021. But the technology and the capabilities are there. It's just the standards, which are for interoperability, don't exist yet. Funding's a huge one. In several of the relief bills or infrastructure bills, I've seen it show up in 3 different places. Somebody's looking for $12 billion with a B to create a next generation 911 network. And even then they say, once we get the funding, it's going to take 10 years. And then finally, this concept of next generation says a device will be able to make a call for service. It could be a camera, it could, chat and video and instant messaging and voice and all these different inputs in MMS. Well, we're looking at what does that do to the call taker that sees something that they'll never be able to forget. So those kinds of things those studies are ongoing, and we're trying to figure out as an industry what's best to do. So you guys got to fit in where you fit in this ecosystem. What changes do you need to make to your service offering? If you're a hosted provider, what do you need to change in your solution? And I'm going to add in one more thing in terms of governance. So one thing I'm going to recommend is when you turn up a system, you got to have an ATP, an acceptance test plan. Make sure the customer signs off that it is compliant from a 911 perspective. One of the things Red Sky offers is you can dial 933 and you'll get an IVR text to speech will say, this is your phone number and this is the location that we discovered you at. If it's not correct, please contact your system administrator. So you want to make sure that they sign off on the ATP. The other thing that they need to sign off in is the care and feeding of that 911 solution. So that if they replace a Wi-Fi access point, then okay, they got to make sure they update it in the wire map, because if they don't, whoever registers in dial 911 has no location information, and that's bad. And that's where the FCC is going to get involved and say, hey, where did this fail? You as the service provider can say, hey, here's where they checked off and signed off that everything worked, and here's where they signed off on the training that they knew what they had to do. If they didn't use the tools that you gave them or sold to them, that's their problem, and you're off the hook. And then, you can follow me on LinkedIn. I talk about the FCC all the time and what's going on there. Or if you have corporate counsel, throw some money at them to, keep up to date on what's going on. Contact information. That's my fire truck. And I think I'm still on time, David.
You are, Jerry.
But feel free to reach out. Yeah.
You're just bringing the
reach out. Yeah.
You were just bringing that presentation into land just at the right time, Jerry. Thank you very much. And I think I'm right in saying that you're the only person I know with their own fire truck. I think.
I thought everybody had one.
Great stuff. Thank you for sharing your wisdom there. Now, I may have missed it because I didn't study every slide, but I don't think you mentioned stir shaken there, did you? In the kind of the veracity of the numbers that you're dealing with.
Yeah, so there's two things. So like a denial of service attack that's going to happen on the legacy network is really somebody just being able to generate 911 calls in a geographic region. There was a case in the Southwest where some kid, as a joke, put a bug in a tweet and people clicked on it because they wanted to win something. And all it was doing was opening up a SIP channel and creating an anonymous 911 call. Well, it took down most of the Southwest. So that's one thing. And there's really very little that, we're doing now, although Stir Shaken is coming in at the carrier level to say, hey, how do we protect not only our global network, but how do we protect our 911 network? And then in next gen, where denial of service attacks is much more, has a lot more potential, because essentially it's the internet coming into an emergency services network. Stir Shaken for that validation and authentication is something we're working on right now.
Great stuff. Well, look, with that, if you just stick around for a minute, I'm going to introduce our next speaker and bring him in. We've got Piotr in the room. How are you doing, Piotr? Oh, I need to unmute there. Can you unmute, Piotr? There you go, he's on.
David, yeah, thanks for asking. I'm okay, and welcome everyone.
Yeah, you're in the room. Good to have you along. The reason I made that link is Piotr is our man at SignalWire who's been doing a lot of work on Stir Shaken, Jerry. And he's got a presentation coming up about that. But Jerry, rather than you sticking around here, what we'd like you to do is transition over into the broadcast cafe, where you can A, watch Piotr's presentation, but B, people that would like to ask you questions, and I'm sure there'll be a lot, but people will have understood your wealth of experience there through that presentation. And so they'll be able to ask you questions. So Jerry, thank you very much for coming along. Pleasure to have you. And,
all right, always a pleasure, guys. Thank you very much for the opportunity.
All the best to you. Bye for now. Take care. And Piotr, Stir Shaken is a gift from SignalWire to the open source community, the library. And I'm guessing you're going to tell us a little bit more about that. But before you do, how did you get into the world of telecoms in the first place, Piotr?
Well, I didn't start with voice over IP from the beginning. I started in financial engineering industry as a software developer, but in a banking area, not in a finance, not in a voice over IP. And then I moved to the UK and I got a job in a company that works within telecom industry, and that's how I started. And then I saw FreeSwitch and I committed a couple of changes to module AVMD, improving it a little bit, and it began.
And here we are. That's great stuff. Okay, well, we need to get your slides up on the screen, and so we can have your presentation. And there they are. So I'll hand over to you.
Thank you very much, David. So indeed, I'm going to talk about Stir Shaken tonight, folks, and we'll be talking about authenticating and verifying calls with Stir Shaken, which is a new technology for making secure calls and for filtering out robocallers and spam. But before we go any further, let me introduce an agenda. We'll be talking, this presentation is going to take about 25 minutes, unless it will take a little bit more. And the topics that we will cover is why I'm talking about this, then what it is, and what SignalWire has got to do with it. There will be some demo and a time for questions. So let us start from why I'm talking about this. Well, I'm talking about it because it's an important technology. It's becoming to be a very important technology in voice over IP in industry that is set to bring an end to robocallers and spam. And even if it is not yet completely defined, we know and we believe and we know that it is, even in its current form, it is robust and good enough to give you a right tool to secure calls and to filter out robocallers and spam. And that's why we work on it and we provide this content, and we've got something for it that I will talk about later. Moreover, some of you may already be researching this technology, and there may be some of you, others who don't. who are not interested in it, or who may dislike this technology, or not, who believe it's not going to work, but they simply will have to get involved in it because it's going to be mandatory from June next year, at least in the US, according to FCC. And now what it is? Well, the name in expanded form may be even more mysterious than the name in the short form. So let me just explain what the technology is. It's for preventing call spoofing by securing caller's ID with SSL certificates issued to trusted service providers and JSON Web Tokens exchange between call origination and termination points. And it's mandated by RFC 8224, which is about call authentication, a STIR in general, a call authentication, and assigning attestation levels to a call. And it's also mandated by RFC 8225, which specifies passport, that is conveying cryptographically signed information about the call in JSON Web Tokens. And you should probably also look at the series of ATIS documents, and the first one to read, the best place to start from would be probably a signature-based handling of asserted information using tokens, SHAKEN, which is extension to passport. And of course, you may have a look at the link provided below, which is something I'm going to talk about in a few minutes. Now, while protecting the calls, we need to exchange information between call origination and termination points. How do we do it? Well, you may send it in a SIP identity header in invite message, to be more specific, and this is the focus of this presentation. Or you may do it via WebSocket, or maybe using some other out-of-band mechanism for PSTN calls, for example. And in more detail, how it works. Well, when receiving a call protected with STIR/SHAKEN, you can perform a verification check of the caller ID. And if a result of this process is positive, then you know that the caller ID you see is the true caller ID that the originating service provider assigned to the call. It has not been spoofed, and it's thanks to JSON Web Tokens. Then you know that the originating service provider is registered on the secure network and trusted because of SSL certificates. And optionally, the originating service provider is legally eligible to use caller ID number you see in the call. That is, origination owns this number on the secure network. This depends if and how TN Outlays extension to SSL certificates is used. And the specs about that extension are quite flexible in Flux. They are shaken in, so they are not yet absolutely clearly defined. We'll talk about it a little bit later. Now, let me introduce briefly SHAKEN framework and the tokens. You got basically three major actors in SHAKEN: TPA, CA, and SP. Policy administrator, certificate authority, and service provider. PA and CA issue certificates to SPs, and SP makes secure calls. Tokens are JSON Web Tokens. There are two important tokens, JSON Web Tokens, in STIR/SHAKEN. The first one is service provider code token, SPC token. This JSON Web Token is signed with private key of PA and is given to SP by PA. It allows SP to obtain certificate from CA when CA challenges SP to prove the right to get certificate. This SP code grant in SP code token is effectively going to be a pointer to an external database which dynamically tracks the numbers associated with the SP code. The second JSON Web Token is called Passport. And this is JSON Web Token that is signed with private key of SP, and it gets created for every call. It's conveying cryptographically signed call data between call origination and destination points. This is an example of Passport. Now, what we've got here is headers and grants. Those three headers are constant. They are always the same. They are mandated by specifications. And we also got a link to the certificate. That header is called X5U and points to the certificate which can be used to decode the hash of this passport, which would be placed here after a dot if the passport is in encoded version. And we've got attestation levels, and we got destination origination. ORIG header is a caller ID. We've got timestamp, and we've got ORIG ID, which is a reference which can serve some extended purposes, which is also not yet clearly defined, but it may, for example, serve as a as a reference to this call, which may be used for assigning reputation index to the SP. So that when SP uses wrong caller IDs or messes with this industry in any way, then it may be given some penalty points. This is one idea of how it may work. Then we got SP code token, service provider code token, which is also JSON web token, and it differs most significantly. It's given by PA, so X5U will point to a certificate of the PA, and it most likely will contain SP code in itself. And here we've got an example of end entities SSL certificate for service provider. And we've got also an example of SSL certificate for certificate authority. You can generate them with a tool that I'm going to talk about in a few minutes. What's important, that key identifier, authority key identifier in SSL and entity certificate for SP will match subject key identifier of CA certificate. Important is that this version number 3, we've got issuer name, which would be a CA name. We've got TN office extension here, and in case of SP certificate, it would point to a URL which can be used to check authority of the SP to use the caller ID. And we've got, we can see that the elliptic curve over 256 prime field has been used to create those signatures, which is also mandated by StirShaken. The CA is very similar, apart that it has CA flag set to true. So it enables this certificate to sign other certificates. This is self-signed ECA certificate. That's why subject and authority key identifiers match. You can print SSL certificate in human readable form with. You can check if CA certificate matches SP certificate. So therefore, if SP certificate was signed by CA certificate with command open SSL verify. In case of errors, you would see some errors, and most often that would be unable to get local issuer certificate, which means that either name doesn't match or key doesn't match, or you don't have required CA certificate in a CA directory. The required certificate would be a certificate that provides a link between CA roots and SP certificates. Now we got a couple of slides showing processes involved in StirShaken. Here we can see how SP obtains a certificate from the CA and how it obtains SP code token, because first he must obtain a SP code token, which is signed by PA, and then he issues a certificate request to the CA with certificate sign request in it. Then CA requires authorization from SP, so SP replies with SP code token and starts polling loop. It will send HTTP GET request to poll the status of authorization. CA sets authorization status to pending and starts checking the web token. If it's good, then it creates an entity SP certificates and signs it with its private key. And optionally, maybe it will insert a TN verifications link to a TN verification service to a TN outlist extension, and then it sets flag to valid, and SP can download certificate. Call authentication is very simple. SP creates a passport, signs it with private key, creates SIP identity header with passport, and places certificate into publicly accessible locations so that terminating endpoints can download set what they need to verify it. Verification is basically as simple as authentication, maybe even simpler. It's just reverse steps. You decode, you take passport out of SIP invite, of SIP identity handler within SIP invite. Then you extract a URL. Then you get a URL to the public certificate. You download it, and you decode passport. You check if passport decodes with it, and you perform X509 certificate path verification on the certificate to see if it's trusted, if it provides a link to your CA roots, and if it's all okay, then at this point you know that data integrity is asserted and SP is trusted. Optionally, you may perform that TN out list check to see if the SP is authorized to use a caller ID. Steps performed by authentication service in detail. So step 1 is obtain certificate from certificate authority. Step 2, for every call, create a JSON Web Token passport with call data, caller ID attestation, trust level for the call, and a link to SP's public certificate that we saw before. And sign passport with TSP's private SSL key. And step 4, add this to the SIP through SIP identity header. And that's basically it. And so input to this procedure is passport params, passport param parameters, depends how you write the method. And the output is SIP identity header. Steps performed by verification service. Verification service obtains public certificate of the originating SP and checks if the passport decodes successfully. So step number 1, get the SIP identity header out of SIP invite and passport out of it. Number 2 is read a link to the certificate of the SP, which is originating of the call, and download that certificate. And then decode passport using downloaded certificate. If the passport decodes successfully, then terminating point knows that the data contained in passport has not been spoofed, changed, or otherwise manipulated by malicious user. And decoding works by simple principle of magic of SSL asymmetric keys, which means that you don't have to have a private key to be able to verify that that key matches the public key. It's enough if you check if the cipher text matches the cipher, the plain text, by using a public key. Step number 4 is check that caller ID in passport matches data from SIP. So we call it identity check. If it does, then terminating point knows that the call has not been spoofed, changed, or otherwise manipulated by malicious user. And step number 5, check that downloaded certificate is trusted by performing X509 certificate path validation procedure. Step number 6, optionally check that originating SP used one of the numbers assigned to it. So the input here is SIP identity header and the output is passport. So can we use it today? Unfortunately, there's a few problems with StirShaken, and they are mostly about policy and establishing a trust framework, the framework of trust within StirShaken. It's not yet clear how you obtain SP code from PA. It's known that in US the iConnective is going to be a PA, but what about other countries? It's not yet clear how to obtain a certificate from CA. How to become SP rules are not clear for smaller telecommunication businesses not having access to numbering plan. And there is the TN outlist extension is shaken in. And what about non-contiguous telephone resources? If you provide this link to the TN outlist check service, then it's assumed that this will point to a list of numbers that SP is authorized to use. But what if you have many numbers that change constantly? And finally, there is technical question about the analysis extension, which is not yet part of OpenSSL. So it's not a very easy to use today. It may be not yet completely defined, and that's probably why the result of polling that I saw online was like on this slide. And there was about 100 participants involved in a StirShaken poll. A poll question was, where are you along your journey to implement StirShaken? And the result was there is 0% of participants have completed StirShaken yet, and only 8% partially completed their StirShaken solutions, and the rest is designing, planning on researching their solutions. But don't be intimidated, guys, folks, because we've got something for you. It's called libStirShaken. StirShaken is a C library. It implements TSP, TSP authentication service and verification service, and also elements of CA and PA. Fill in the gaps in specs with same approach. We use libjwt for JSON Web Token and libcurl for HTTP requests. So we use Mongoose for handling of HTTP requests by standalone CA process, and it ships with a tool called StirShaken, which I will show you in a moment. It's integrated into FreeSwitch already. Here we got a couple examples of how using libstir can look like in practice. On this slide, we run certificate authority. Here we create SP code token. I will explain those parameters when we get to the practice. This is how the SP code token would look like when you create it. And then you can check the SP code token with stirshake JWT check command. And you can, of course, download certificate with command sp cert request. This will perform all that ACME downloading procedure, requesting certificate from CA. In FreeSwitch, we use libstir for implementation of authentication and verification service, and this is how authentication service looks like in a nutshell. You provide parameters to the passport, parameters of the passport, and then you call stirshake and JWT SIP identity create, which will create SIP identity header for you. And you would put we then put a flag on an internal variable of Sophia so that it appends this to the SIP invite in a SIP identity header. Verification service looks like this. When the call hits the box, we detect that there is SIP identity header, and then we extract the SIP identity header, and you input this to the stirshake and verify procedure, which will give you the status of verification check, optionally giving you also a certificate and passport out of it. So let's go to the demo. This is our setup. We will make some calls. First, I will show you how you can obtain a cert from the standalone process, from the folder which is from non-FreeSwitch implementation from the scratch. And then we will make some calls using FreeSwitch implementation of TSP using libstir. So we will have one FreeSwitch that is running authentication service. It will make a call to the other FreeSwitch which is running verification service, and FreeSwitch with verification service will talk to the user that has open Cantina over Vertu and Relay, so that we can provide this information about the caller ID to the user. So here we got our testing setup. I am now in a test folder. And first thing that we are going to do is we will export libstir to be easily accessible. Under the stir name. So I will use stir instead of that long name. And because I don't have anything, I start from generating a keys. Folder is empty, as you can see. I got only commands there. So I generate a keys, public and private key. Then once we got our keys, we generate certificate sign request. Certificate sign request take those keys that we generated, and the name of our SP, which will be cluecon SP code, which we would get from the PA, and that's it. The output will be csr.pem. You can inspect the result with this command, request. And it has our cluecon SP name and SP code token 100 in TNLTS extension, and everything else is as it should be. And then you can make certificate sign request to the CA. The only problem is we need a SP code token. So let's assume that this is our join CA and PA, and it will token. So how does this work? It needs a private key of our PA, of course, to sign a token, and we provide a URL to the publicly accessible certificate of the PA, and we give an SP number. We assign an SP code to the SP here, and we say what's the name of our PA. So it's known who issued the SP code token, and we give a name of the result. It will be SP code token txt, which exists in this folder, so libstirshake can refuse to overwrite it. So I'll just remove that. We got our token, then we check that the token is okay with JWT check. And give a public key that we want to check against, which will be test reference PA. Because I'm using our test reference implementation for CA and for PA here that you will find in a test folder of libstirshake. And be verbose, very verbose. So we can use it, so SP can use it for downloading certificate request. And we give the output name will be sp.pen. Please be very verbose. Not connect to server because we are not running CA yet. So let's start CA with a command CA. We started CA. We've given a private key, a name of our CA, and serial from which it should start issuing certificates, iterating them, expiry of the certificate, and a certificate of the CA itself, and the URL of the service, which can be used for checking authority of the SP over the number, which will be embedded in TN outlist extension for all the certificate we will be issuing. And now we can obtain our lovely certificate, and will be saved under the name sp.pen. Now the polling process takes place, and once it's ready, we can inspect our certificate with a similar command. SignalWire TCA test issued our certificate number 3. It's a good subject is cluecon. It's okay, and the key will match. We shall check that. So we can check that the certificate match with this command. Reference certificate and our SP, it matches. So this is how it works. With that certificate, you are ready to make some calls. So how about starting a free switch and making some calls? Let me remove shaken in so we can see what's the configuration of it. We will see that authentication service is configured here and verification service is disabled. And everything is ready because everything is in a folder created already. But I will remove everything and will generate required that run through all the steps in free switch. We need to remove certificate sign request folder. The is using for authentication service. And we will remove all SP stuff. And now if we reload, it will tell us that there is no private key, so it can't start authentication service, but no problem about it. We will get it. We'll create it. So you create a keys, and you would create a certificate sign request. It would use all this data that you configured in FreeSwitch configuration files. And then we can send a certificate request. That certificate, and with that certificate, we can make calls that will be true, that will be authenticated with shaken, and so then you can verify the caller and you can reject false fake callers. So first, the call we're going to make is a standard call, but protected with stir shaken. So we assign cluecon trusted demo as a caller ID, and we will see that it will make a call to our Cantina user, and Cantina user will be presented with status of a verification check. And you see that caller has been verified, so we can safely answer the call. And just one thing I wanted to show you here is that how we get that we indeed set a shaken variables on a virtual relay. So this is how JS code finds the result of the verification check. Then we can make a standard call, but it will not be protected with shaken. So let's have a look what would happen then. Then we are presented with similar info, but this time it says, I mean, the name form is similar, but it says this caller has not been authenticated. There is no info about the caller, so you can accept it at your own risk. And if you change your mind, you can then hang up. And finally, I would like to show you an example of a fake call. I got a special variable implemented here named fake caller ID. When I set it to true, like I'm going to do now, what's going to happen is it will work like before. But before we will create a passport, and we will insert a passport in an identity header. But just before sending a call, we will change caller ID to be fake caller ID, something else. So then SIP from will be different. And I will enable Sophia so we can see that. And then we can see that the call is suspicious, caller fake verification. It's clearly suspicious, it's COVID-19 second wave. Don't trust it. And if we just to have a look at what's happened, how authentication works, you can see that when the call starts, we check that it should be authenticated with stir shaken. We create a passport, and remember that I used the fake variable now. So the passport was created for a cluecon trusted demo and was inserted into the invite with here it is, but we changed that from to be COVID-19 second wave, and that's why we saw the call has failed. There's a couple of amendments to the stir shaken. We will keep you on track with all of them. We will enhance lip stir shaken to stay up to date. There are going to be Most importantly, it's diversion O for transfers, APH for resource priority header for prioritizing calls, and out-of-band shaken and delegated certificates, and announcement to SP code token will definitely include them. And that's it for today. Thank you very much. And this is how you can reach me, folks, if you got any questions.
Thank you very much, Piotr. Excellent information. It's something that everybody hates, the robo-caller, and something of a tool in the arsenal for dealing with it is much appreciated. There was a question that came in the chat, so let me just read that out to you. And that question was, what is the size of the identity header with StirShaken, and does it require TCP instead of UDP to send SIP?
Oh, you can send, you send SIP normally. This doesn't really matter because it's not about how this information gets to the endpoint, but it's only what it is. So you verify what is delivered for the SIP. You receive a SIP identity header, you get passport out of it, and it points to a publicly accessible location of the certificate that should be used to check this JSON Web Token, the passport. If it doesn't match, then you know it's wrong. It doesn't really matter how it get to you, how it was.
All right, that's great. There's probably going to be more questions over in the broadcast cafe. So if you could make your way over there. We've got a couple of special guests to bring in. So we'll say bye-bye to you, Piotr. Thank you very, very much for your presentation. That's great. We've got Andy Abramson in. Hi, Andy. How are you doing? You're muted currently, Andy. There we go.
I'll blame it on the producer. Hands-free, contactless. No, what a great show you've put on, David. I mean, everything today, and even yesterday, what I've been hearing, what I've been seeing, you guys are just really nailing it and really doing a great job at educating the world about all the great things available through open source, the whole free switch generation, as well as all what's new with SignalWire, especially what we're looking at, something that's really amazing, something called Work.
Indeed. Yeah, well, thank you very much for your participation, Andy, in co-chairing the dangerous demos earlier with James. And there was talk that you wanted a few words with Tony. So I'm going to hand over to you and disappear off. And thank you again.
Great. Tony, what a great demo and what a real dangerous demo you put on with Work. And I think it would be great to get a good background on just the genesis of how Work came about and why you feel that Work is the right product for the right time.
Well, when we started FreeSwitch in 2005, one of the first things that we got working was a conference module so that we could have, like multi-party conversations. That's going back to like 2006 or something, something we used to use Asterisk for before that. As soon as we got the thing working, we would go in there and just kind of dog food through it. We were actually writing FreeSwitch while, spending hours on the phone. And that really kind of never changed. The world around us transitioned from like flip phones and no one had internet to suddenly having like WebRTC and video all over the place. When we started SignalWire, we had this notion that we would continue this ability to work remotely because many of us are inspired when we're not always in an office, or like we're moving around, or we have lots of stuff to do, but we're still working. We wanted to be able to stay remote. So that was like a necessity born from the way that the kind of culture of our employees operate. So unlike when we had this kind of forced work remotely thing upon us, it wasn't like a thing we did because of that. It's sort of like what we were already evolving to anyway. It just kind of got accelerated when we realized how important it was to finish it. So, as you saw this morning, Evan can work from the ocean. You never know where you're going to be. So we decided that, we would take all the functionality that we had kind of all over the place tech here and there and ideas and storyboards. And we'll just get an MVP out the door. So yeah, it is a pretty dangerous demo, I guess, because literally we're like in between the sessions and stuff, we're still kind of hacking on the code a little bit here and there, poke at stuff. Every night we did a new update. So we learned a whole bunch of stuff from having like 400 people calling in at the same time. So it helped polish the stuff even more. So that's really kind of, we thought that we could take this kind of paradigm and simplify it, and then we can continue to build on it. So there's a whole bunch of integrations and roadmap that we have coming, and there's a lot of feature requests already.
So this isn't video conferencing, and this isn't a webinar service. This is something totally different. And I think it would be important for everyone to understand how you see this being applied by the workforce today, driven a little bit by the pandemic of COVID-19, but really how people are working today, because people like you and I, we've been working from home and remotely a good chunk of our careers. This isn't something new for any of us, but it might be new for others. So I think letting people understand what makes, I used to say me too, me also, me different. Work is definitely in that me different category. So it'd be great for you to talk about the differentiations.
Yeah, that's kind of like one of the essences of what we're trying to capture is sort of something that we've all taken for granted. So, you know, some of the tried and true early cluecon attendees, the kind of people that come to cluecon since 2005, might have already understood this lifestyle to some degree. Like a lot of us here could craft some kind of weird service and make ourselves a little conferencing box, and like it's almost like wizardry, right? But like there's millions of people in the world that just don't have time to figure that out. So I think that's one of the most important things is finding a way to bottle up all the stuff that we take for granted and figuring out how to package it to something that other people can appreciate really quickly and a lot simpler, and don't have to do as much wizardry as we do to kind of make it happen. And also kind of like the human engagement factor. We have this kind of like a way to emulate our culture through the app. So we don't necessarily just have like super stale meetings where we only come and there's an agenda and we leave again and everyone can't remember where they're going and all that kind of stuff. We have like entire day, business day will go by and the rooms will stay lit up the entire time. You know, like what you see at cluecon is sort of what we call open house mode, which is when we're having a conference or something and we give you all these rooms and you can pick which one you want to go in. When we get in more of an office context, then you have to have an authentication to get me into the rooms. You might have a few public ones for guests, but then we can wander around that same way. You know, I want to go over and talk to the engineers. You know, we have meetings in there. So it's unlike something where you just use it when you want to have a specific meeting context, kind of derived from the WebEx kind of thing. It's more like it's just like a place to be while you're working so that you can always talk to everybody else in the company.
Where do you see this going? To wrap up this short interview with you, where do you see work going if COVID-19 work at home continues, and where do you see it going if people end up migrating back to the office?
Well, I think that there will be a lot more remote workers now that they figured out they can. Some people might not be able to. There's certain jobs you have to go to work, right? Like if you're a restaurant or something. But I think there's a lot of people that didn't know that they could get away with it, and they're starting to figure it out. So I think even when they go back, they'll still want to do it. And I also have ideas for kind of incorporating it into that kind of paradigm where we have some like physical attachments also, like connect entire rooms into the virtual ones. So we have all kinds of different stuff to do in that category. And also just for like the times when you are moving around, because a lot of people travel a lot. So you might always have a certain number of people in flight and you kind of lose track of them until they're back, but now you can kind of like just talk to them the whole time. We've had I've been going on airplane flights and like using the app from his mobile phone. Like, well, he doesn't just jump in the ocean. Sometimes he tries it in airplanes too and other crazy places. So I think that we have even more ways to connect. There's a kind of a push for doing kind of ways to hang out like this. We used to do it a really long time ago in a more basic form that it wasn't really something you could scale, which is like just having like a weird conference call floating in the internet once a week, and everyone would come in and like discuss stuff for hours. But you had to be like a wizard to be able to figure out how to get into it and that kind of thing. So it's just more and more of taking stuff that we already know is cool and making it easy enough so an ordinary person without like endless skills dedicated to this kind of thing can leverage it for other use cases.
Well, it looks great. It sounds great. It has a lot of future, and I think we're only scratching the surface of work. And work will also have implications in play, and it will also have implications in life. So I think you've got the foundation here, which is a great first step. And being that it has stood up and stood the test of cluecon 2020, in the way of a dangerous demo, as Steve Smith from Phonitive said today, your team are all the winners of a demo award from Dangerous Demos, because you've been able to do something that was risky, but you did it so elegant. You didn't crash and burn. You weren't eligible for the fan vote, but you certainly developed something which would win a Swan type award from Dangerous Demos. So on behalf of the judges, we bestow the big DD award to you.
Thanks. I appreciate that.
And thanks, Andy, and thanks, Tony, for coming in to have that little chat. We need to round off now, so we'll say goodbye to you. Thank you so much. And we're going to have, thank you, Tony. Thank you, Andy. We're going to get Abby into the studio. I wonder if she's managed to wander in just yet, because it's the big moment.
I am so excited, everybody. It is time to give away the grand prize, this engraved MacBook Pro. Woo! I can hear all of you cheering. I can hear it. But first, a little bit of a teaser. We're going to be giving away 2 prizes and then the MacBook Pro. So the first prize we're going to be giving away today is a ClueCon messenger bag. Very exciting. So I'm going to go speak with my team really quickly, and let's see who wins the ClueCon messenger bag. For those of you just tuning in, this is randomly drawn from all of the participants who came to ClueCon Deconstructed this year. So the first winner is Tom Lynn. Tom Lynn, you are our lucky winner of the ClueCon messenger bag. Congratulations to you. Yay.
Great stuff.
All right, the second prize we're giving away today is a free switch shirt. Let's give away this free switch shirt. It's not this shirt. This one's mine, but you can have your own. This is from a couple ClueCons ago. So let's see who wins our free switch shirt. And the winner randomly chosen is Chris Webb. Chris Webb, if you're listening right now, you just won a free switch shirt. Yay! And last but not least, it is time to give away this beautiful, beautiful MacBook Pro. Wow! Engraved in this, on this very location, by the way, with this wonderful ClueCon Deconstructed graphic.
Cool stuff.
So, the winner of this beautiful laptop is, drum roll please, okay. And the winner is Eli Smith. Woo! Eli Smith, if you're listening, you just won this beautiful MacBook Pro.
Congratulations, Eli.
We're going to ship it the old-fashioned way and just, it's on its way right now. So before I officially say goodbye, I do have a couple quick announcements. Make sure you follow us on our social media accounts and stay in the Slack channel at SignalWire.community. You can ask any questions you have about FreeSwitch, about SignalWire, or about ClueCon, and be up to date on what ClueCon is going to look like next year. We also have a swag store open for the next week. So if you're interested in getting one of these t-shirts for your own, unfortunately, we do not have the laptop, but every other piece of swag we've given away is going to be on that website. We're also giving everybody who attended ClueCon a free ClueCon t-shirt. So keep an eye on your inbox. We're going to be sending all of our attendees an email. And if you came to ClueCon Deconstructed but didn't register, make sure you register so you get on that mailing list so that you can get your free t-shirt. And I just wanted to give a big shout out to everybody on the ClueCon team for making this happen. You know, we had such a great time, but you know, things are a little crazy this year. And so everybody put in so much hard work to make this happen. Thank you to Jill and Anthony Minasali, Jason, Gretchen, Danny, Kat, Sherelle, Cassie, Kevin, Sharon, and of course you, David, as well as our sponsors and our speakers, and of course all of you in the community who made this event have that great family feel that we're always looking for. And now it is time for the Gigabit reception. Make sure, if you're not sure where that link is, it's on our social media channels, as well as the Slack channels and our website. We've got karaoke rooms, open jam rooms. We're playing Star Wars. We're going to be chit-chatting. Bring your own drink. And I think it's time to pop open some champagne and celebrate a great ClueCon Deconstructed.
It certainly is. Thank you very, very much, Abby, and thank you for everything you've done. Thank you to all the workshop people, the people that did the workshops on the Tuesday, all the people that participated in the Coda Games on Wednesday morning, all of our speakers, the Dangerous Demos participants as well, and especially to our sponsors. You're going to see their names pop up right now as Abby and I say goodbye, and we'll see you in the Gigabit reception, 4:30 Central.